the beaches, the first objective of an enemy attack. These beaches must be protected by obstacles. Beaches with the right kind of obstacles will repel the enemy if you know the what, when, where, and how of the proper beach obstacles. Beach obstacles will delay, harass, confuse, and immobilize the enemy long enough for supporting fire to destroy him. Beach obstacles can be roughly classified into three basic groups. Offshore obstacles, which are placed to be in the water at all times. Tidal zone obstacles, which are placed to be sometimes in and sometimes out of the water depending upon the tide. And shore obstacles, which are placed back from the high tide waterline. The primary mission of our defending forces is to stop the enemy as far away from our beaches as possible. We have planes and ships to do the job. But should the enemy penetrate these defenses, he is still faced with assaulting the beach. A beach that has been fortified with obstacles. These stumbling blocks should fit the overall plan of defense to stop the enemy at his earliest point of penetration. Construction of offshore obstacles, such as this mined raft, is the first step. These rafts consist of 3 timbers of logs fastened together. Several mines are attached to each raft. These mines are then protected from seawater by applying a waterproofing material. The raft is moored by cable to 3 concrete anchor blocks so that it floats just under the surface of the water at high tide. The mines are detonated when they are hit by the landing craft. Stakes made of logs, rails, bars, and precast reinforced concrete piles make effective obstacles. The log type is jetted or driven up to 12 feet into the beach. The top of the stake is cut at a 45-degree angle, and mines are attached to make them effective against steel-hulled craft. If time permits, anti-personnel mines are attached to these or other stakes to produce a more formidable barrier. They are attached with clamps or wire and covered with barbed wire to hinder their removal. Tripwires are attached to the anti-personnel mines. At high tide, these tripwires will be completely submerged and consequently hidden from the attacking enemy. Another type of stake obstacle is the nutcracker, which you see at the water's edge. The nutcracker appears to be a simple stake above water, but this innocent-looking stake may be attached to a box-like base enclosing a mine or anchored to a crude platform fixed with a mine. The stake acts as a trigger, and when it is moved by landing craft or vehicles, the mine detonates. There are several variations of the nutcracker. One is a push-pull type in which the mines are attached to welded or bolted steel members. Another, an expedient-type nutcracker, employs a push-and-pull type fuse. Still another is the angle mine obstacle. In this one, the landing craft hits the stake as it moves forward, causing the mined end of the obstacle to swing up and strike the bottom of the craft. In a staked area, there might be 10 nutcrackers, or 20, or 100. Or some stakes might be just that, stakes. But the enemy isn't sure. This delays him, confuses him. And that's one of the advantages of stakes. The enemy never knows what's on the other end. An obstacle that causes offshore beaching and will overturn small craft is the timber ramp. It consists of a large log supported in an inclined position by legs. Crude blades of steel are inserted in the upper surface of the ramp. These tear holes in the underside of landing craft. Mines attached to the end of the ramp detonate on contact with enemy landing craft. A notch cut into the log behind the mine breaks off the end of the ramp when the mine explodes, leaving the ramp still effective. The ramp is inclined 30 to 40 degrees, and the height will vary according to the depth of the water. At high tide, the top should be 1 to 2 feet below the surface, as seen on this model. The supporting members should be driven, jetted, or dug in by hand. To make an effective blockade, the ramps are inclined seaward and placed in rows parallel to the coastline at close intervals. Obstacles are constructed in many shapes and types and from a variety of materials. Here is a model of the pipe scaffold consisting of prefabricated triangular sections of welded steel pipe, which can be used onshore or underwater. The triangular sections are easy to transport and are erected in the field with horizontal pipes bolted onto them. To make the pipe scaffold even more effective, sharpened angle irons or other steel members are inserted into the pipes facing seaward. It can then be placed so that it becomes another menace to the invader, helping to make him a target and destroy him before he reaches the beaches. This is how a landing craft can be impaled on the sharpened angle irons of the pipe scaffold. As we approach closer to shore, other obstacles, such as the crib and cairn, can be effectively employed. The crib is a cage of wood and wire filled with rocks, rubble, and similar material. A line of cribs joined with barbed wire or cable becomes an intermittent barricade. Cribs may be square, triangular, or complex in design. Their dimensions vary with each mission. Because the surf would pound them to pieces, they are used mainly on reef flats where the surf is mild. They are first built on shore and then carried out into the water to be placed at intervals. Once in place, they are then loaded with rocks and other materials to provide a formidable obstacle. The cairn or rock mound is an expedient type of crib and can be used for the same purpose. It consists of mounds of rock or similar material piled high and held together with wire. In this cairn, the rocks assume a mound shape, but cairns may be roughly cubical and vary considerably in size. However, its loose construction makes the cairn more vulnerable to the surf than the crib. A concrete binder makes both obstacles more durable and tougher to assault. When assaulted, offshore obstacles should delay the enemy and damage his landing craft in the water, making it difficult for him to establish a foothold on the beach. Thus, the invader is subjected to withering fire from our supporting weapons. Should some of the enemy pierce the outer defenses, they must then assault a second barrier, tidal zone obstacles. These obstacles are placed where they will be partly or wholly submerged, depending upon the run of the tide. However, they are equally effective in or out of the water. Because heavy surf can wash away the foundation of some obstacles or knock lighter ones apart, tidal zone obstacles must be tough and durable to remain effective against assault. A good tidal zone obstacle is the skeletal fence or scaffold constructed of wood or steel and used in conjunction with other obstacles. Log scaffolds are practical if native timber is available near the beach defense area. The vertical post should be about 1 foot in diameter and 12 feet long. These are jetted or driven into the ground 4 to 5 feet so that they cannot be pushed over easily when struck by the enemy landing craft. The posts are placed at intervals of 6 feet. The horizontal members are attached to posts with cables, heavy wire, or drift pins. They should be about 8 to 10 inches in diameter and long enough to be secured to 3 posts. To increase the strength of the scaffold, the ends of the horizontals should be staggered so that they do not butt on the same post. The posts are notched to receive supporting braces, slightly smaller than the posts. The braces are then set back at a 45-degree angle into the ground, as deeply as necessary for secure footing, and are attached to the posts with drift pins. This makes a formidable tidal zone obstacle capable of stopping landing craft.